Welcome to Leading Edge Skills for a free session on some key networking concepts. My name is Omid. I'm a network engineer trainer at Leading Edge Skills. I have over 10 years of experience. Today we're going to go into a deeper explanation of networking language. The first thing we're going to look at is how networking protocols work. Then the second thing we're going to understand the different types of networking topologies and what are the best ones. Then we're going to look at how a network infrastructure is set up. And after that, we're going to understand thin client and thick client networking, which gives us a better look at how the server works. Then we're going to jump into network and packet delivery and how things move along the network. Finally, we're going to look at the contrast of static and dynamic IP. Let's get right into it. Networking protocols can be hard to follow, since there are so many. But today, we're going to break down some of them, so that you are prepared to understand how they tie into networking. Most importantly, how are they used? A very basic and most important protocol we need to understand is TCP/IP, which stands for Transmission Control Protocol, Internet Protocol. This is how devices exchange data to and from the network, by breaking down the message like an email into packets of data to reach its destination. The next one we're going to talk about is UDP, which stands for User Datagram Protocol, which is a communication protocol for reasons as a video playback or a DNS lookup. These speeds are faster due to not establishing a connection before data is transferred. Another protocol we're going to look at is ARP, which stands for Address Resolution Protocol, which broadcasts a request packet to all the machines on the local area network to see if any machines using that particular IP address. There's a few protocols that transfer files across the network. One of them is called a FTP. The other one is a TFTP. FTP stands for File Transfer Protocol that transfers computer files from the server to another computer securely. TFTP means Trivial File Transfer Protocol. Transfers files to computers with no security. Have you ever sent an email and wonder how does it get there and where does it go? Well, here's a protocol for you to get a better understanding. SMTP means Simple Mail Transfer Protocol. SMTP sends and receives email. Basically, SMTP sends messages to a server for forwarding purposes. So there's a few ways to get onto your network. One of them is called a SSH, and the other one's called Telnet. Well, this protocol SSH is a network protocol that creates a secure way for two computers to connect when they are remote. Telnet is used to access a computer and to have a two-way text-based communication channel between the two machines. But I might remind you, Telnet is not as secure as SSH. Have you ever tried to get to a website and seen the beginning say HTTP or HTTPS? Well, those are protocols. HTTP is a hypertext transfer protocol, which resides in the application layer and it's used for transmitting sound and media like HTML. HTTPS means Hypertext Transfer Protocol Secure, and it's used for secure connection over the network. This protocol uses encryption. I would prefer HTTPS when you're logging into banking, looking at patient information, or anything that's kind of information sensitive. I would definitely use HTTPS because it's secured. HTTP, on the other hand, well, not so secure. The next topic we're going to talk about is network topologies. What are topologies? What does it mean? Well, have you ever seen a network and you have a router, computers, devices, and everything's connected to it? But the question is, what is the best setup to set up a network? What's the fastest, more efficient, and reliable, and has good redundancy? For example, if one or two computers go down, is the network down, or a server goes down, is everything down? We're going to take a look at that. What is a network topology? A network topology is how a network is set up, including how the network nodes are set up with each other. Basically, it's your network setup and how it looks and it's arranged. Let's talk about network topologies. The first one I want to talk about is star. For example, there's a switch in the middle and PCs on the outside. If one PC goes down, the rest of them are still up. Next one I want to talk about is mesh. Mesh has two switches. If the left side goes down, the right side's still up. If the right side goes down, the left side's still up because they're all connected to each other. Another one I want to talk about is ring. Ring, all it takes is one to go down, the rest of it's down. Not very good when it comes to redundancy. And similar to that is the tree. Let's say, for example, this PC is down. Well, the PC below that, they're all going to be down. Not as good as well when it comes to redundancy. My next one is fully connected. Oh, that's a really good one. Each PC is connected to each other in multiple different directions. So if this PC is down, well, they're still up. If you look at all the cables that are connected. Another one is a line. A line pattern, well, is not as good. If one goes down, the groups in front of them will be down. Not as good when it comes to redundancy. And finally, we got the bus. The bus topology, well, each end needs to be terminated. And if they're not, you'll get a bounce back, a reflection, and that messes up the signal path. So for example, if each computer has its connection to the main line, they all have redundancy. After looking at network topologies, I want you to ask 3 questions. What network topology works best? Which topology is mostly used? Which topology is a liability? These are good questions to ask yourself before you set up your network topology. That way you have a better understanding of what's needed. Next, we're going to talk about the inside and outside infrastructure and go into more detail on what it looks like. Let's take a look at what inside and outside infrastructure looks like. Inside infrastructure is hardware, software, systems, and devices. This is where computing and communication between users, services, applications, and processors take place internally. The outside infrastructure is a demarcation point to where administrative control of one network ends all the way to the ISP, or Internet Service Provider. What we have here is an inside and outside infrastructure diagram. When we look at the internal LAN, what we see is computers connected to our internal network on the right side. But when we send outside our information, that's the outside infrastructure, and everything goes out the router to the modem, to the ISP, into the internet, and it goes out into the world. That is the outside. A good way to understand that is the internal LAN is us, and the external WAN is the outside world. In this section, we're going to talk about thin client and thick client networking. And how does it work? The thin client, the device the user uses in order to connect to the server. A thick client, the server, which sends information back to the computer. Here's a visual of a thick client server connected to a thin client computers. For example, the server sends information to the computer, then computers send it back to the server. In this next session, we're going to talk about network packet delivery. I'm going to explain how a packet is sent off into the network. Sending packets. A packet is a small segment that is sent over a network and divided into packets. The packets are recombined by the computer or device that receives them. Here's an example of how a packet is sent. Let's say the person wants to send a packet or a file over the network to another PC. The PC they're trying to send to is 192.168.1.2. So the user sends the packet and it goes through an UDP protocol. As it goes through the UDP protocol, it gets sent over through the switch. Then from the switch, it gets received to the PC. And that, in a nutshell, is how to send a packet. And this is our last and final segment. We're going to talk about static and dynamic IP. What is a static and dynamic IP? A static IP is an address that stays the same and never changes. A dynamic IP address changes continually over time. Here's another visual of what a static IP and dynamic IP is. Typically for static IPs, we use printers, scanners, routers, switches, and servers. Devices that don't need to change our IP, they need to stay the same so we can get to them. On the other end, we have dynamic IP. Things like laptops, cell phone, PC, tablets, devices that connect to the server or the network. They need to have an IP that changes. Thank you for attending this session. To attend my full session, please join our free webinar on June 11th, 18th, and 25th at www.leadingedgeskills.com.